So the decision-making criteria, the first one we have is max. Okay, so max means maximize maximum value of alternatives. Maximum value of alternatives. Then we have the other one is max mean. Max mean means so max mean, this means maximize the minimum value of alternatives. The minimum value of alternatives. Okay, that is on the aspect of max mean. All right. Then we have the other one called minimax. This is also called the regret table. So regret table. This means, okay, minimize the maximum value of alternatives. So it means minimize the maximum values of alternatives. Are we together? Are people with me so far? Okay, so we can move on now. Okay. So now we are going to have this question now. We have this question here that says the following pair of, okay, the following pair of for 3 mutually exclusive projects. So we have project 1, project 2, project 3. And then for this one, we have the future state of the market. You have so for project 1, project 2, okay, and the project 3, okay. So P1, P2, and P3. So we have the state of the market being poor, being fair, and then being good. Okay, so we have the values 20, 50, and 90, negative 10, 140, and 150, negative 200, 30, and 250. So those are the values that we have. So which project can be chosen using the minimax, which means the minimize the regret table. Okay. So, and the probabilities are given the 0.3, the 0.5, and the 0.2. Okay. So let me go back here. So the projects that we have the project 1. Okay, so project 1 here. Then we have project 2. Then project 3. Okay. Okay, so we have these aspects here. All right. So for this one, we have the future state of the market being poor, good. Okay, so from here, we have the future state of the market. So, okay, future state of the market. Okay, we have poor in this end, fair, and good. So here we have a 20, a 50, a 90. Then you have negative 10, 140. So negative 10, okay, 140, 150. You have negative 200, 30, and 250. Of course, the probability, we have the probability of 0.3, 0.5, and 0.2. Okay. So they want us to do a table called min max. It's also called the regret table. So min max is also called a regret table. So what we do for min max is that in each project, you need to actually, okay, in each project, you need to subtract. So you got the largest value here. So we're going to have project 1. Then, of course, project 2. And of course, we have project 3. Okay. So we will be able to subtract. So the first one will be, so here the economy is too poor, fair, and good. So here it will be, the largest value is 90. So it will be, you come here and say 90 minus 20, which is 50. 90 minus 50, which is 40. Then 90 minus 90, which is 0. Then the other one, maximum is 150. So it will be 150 minus 10, which is 160. Then the other one will be 150 minus 140, which is 10. Then 150 minus 150, which is 0. All right, so we're getting the maximum value. In this one, maximum value was actually, it was 90 here. This maximum value is maximum value for each project. Okay, so that's what we are subtracting from all those ones that we have. So from these ones, we're subtracting these ones using the maximum value, subtracting all these. So this one will be 250 minus 200, which will be 450. So now the other one will be what? 250 minus 230. 250 minus 30, which is 220 here. Then the other one is 250 minus 250, which is 0. 250 minus 250. The answer is 0. So what are we simply saying? What we are simply saying is that in this given we need to choose the one which is the maximum. So here, as we come here, we are going to have project 1, project 2, project 3. Okay? Project 1, project 2, project 3. So we have these scenarios of the economy being poor, fair, and good. Okay? So what is going to happen is we are going to, okay? We are going now to, okay, so the figures that we have 50, 40, and 0. 50, 40, and 0. Then the other one is 160, 10, and 0. Then the other one is 450. So 450, 220, 220, and 0. So the question is asking us to do what? To find the minimax. So to find the minimax, which is minimize the maximum value of alternatives. Minimize the maximum value of alternatives. That's what it means by minimax. So minimax means minimize the maximum value of alternatives. It's a regret. Minimize the maximum value of alternatives. So here we come. What is the maximum value? Maximum value is what? Maximum value is 50, 160, and 450. So here, min max means minimize maximum value of alternatives. Maximum values of alternatives. So therefore, invest in project 1 with a minimum, okay, for maximum value. Invest in project 1 with minimum, okay, of maximum value. Okay, or what? Or 50. I don't know. Have you followed so far? Are you following? So the maximum value is 50 here. Here it was 160, and then it was with 4 what? 450. So the minimum for this maximum value is a minimax. Minimize the maximum value of alternatives. So you have gotten the value of what? Of 50, the minimum for these maximum values. That's a minimax. All right. Then the other question is asking us to find which project can be selected based on the expected value rule. So expected monetary value. Okay, so let's find the expected monetary value. Okay, that's number B. Expected monetary value. So this is what it means. Expected monetary value. So is equal to summation of probability, okay, by your value. Summation of the probability by what? By the value. So project 1 expected monetary value is actually equal to 0.3 multiplied by 20 plus 0.5 multiplied by 50 plus 0.2 multiplied by 90. These values we are getting them from this table, the original table that we have here. Okay? The original table that we have here, this is why we are getting these ones. So our value will be, okay? So this one will give us what answer? 0.3 by 20 plus the 0.5 by 50 plus the 0.2 by 90 is 49. So project 2 expected monetary value is actually equal to 0.3 by -10 plus 0.5 by 140, then plus 0.2 on 150. Are we together? Are you able to get me?
Yes, we are together.
Okay, thank you very much. So meaning here it will give us what? 0.3 by -10. Okay. Then plus 0.5 by 140 plus the 0.2 by 150. What are we getting? 97. Project 3 EMV is actually equal to what? You are getting the multiplication of these ones, 0.3 by -200. Okay. So 0.3 by -200 plus 0.5 on 30, then plus 0.2 on 250. The answer will give us what? So 0.3 by -200 plus the 0.5 by 30 plus the 0.2 by 250. The answer is 5. So therefore, invest or select project 2. Project 2 with the highest expected monetary value of 97. That is the final answer. Is that okay so far?
Yes, it's clear.
Thank you very much, madam. So expected value with certainty now. Let's find expected value. Expected value with certainty. When are your exam?
Let me just recheck the calendar.
Okay, no problem. Let's move on with class. So expected value with certainty is equal to, so you come to the table here. The table that you are going to come for is this same one. So in this column, regardless of which project, which one is the highest possible value here? Is 20. So you get a 20 in each column for each state. So 20 would multiply it by 0.3. You've seen the table, right?
Yes.
So 20 by 0.3. Then the largest in that other one is 140. So plus 140 on 0.5. Plus the other one will be 250 on 0.2. Is that okay?
Yes, it is.
So this is expected value with the certainty. So it will be 20 on 0.3 plus 140 on 0.5, then plus 250 on 0.2. So give me the answer now. The answer will be 20 by 0.3 plus 140 by 0.5, plus 250 by 0.2. So this one is giving us 126. So meaning expected value with perfect information. Expected value with perfect information is equal to expected value with certainty minus expected monetary value. That's a formula. Okay. So it will be 126 minus expected monetary value was 97.
7.
So we subtract those. 126 minus 97 is giving us 29.
9.
Are we together?
Yes.
It's giving us what? 20?
29.
29. So that is what we have. So that is the answer there for expected value with certainty. Is that clear?
Yes, it's clear.
Okay, so what we do is let's move on to question 4. If you have followed, so we can move on to question. So that is what they said. What's the value of this one? So we have answered the first, second, and third. Okay. So this is just one.
So the 29 is for the third.
Come again.
The
29,
29 is for the third.
29 is for the third, yes. So the 9 is for the 9 is for the third.
Okay.
Okay. Is that okay?
Yes, it is.
Okay. So now let's move on to the other one, the other question. I'll give you, you have a calculator with you?
Yes.
Okay, so I want you to, using the same concept, we are looking at question 4. Question 4 says the X limited, right? Can you choose from 5 mutual projects, each lasting for 1 year, only with the net cash inflows of, okay, these ones here that we have. Focus annual cash flows and the solid probabilities are shown below. Which project should be undertaken on what basis? So I want you to use the EMV. So let me just do for project L. Then I'll give you 5 minutes to do the other one. Okay? Is that clear with you?
Okay.
Yeah, so we are going to have the project. The first one is 500 for poor. You've seen for poor there, 500. Then we have the good and excellent. So 500, 470, 550, 400, 550, 570, 450, 400, and 475, 360, 400, and 420, 600, 500, and 425. So let me just do for the first one. Then I'll give you 5 minutes to try the other ones, right?
Okay.
Is that okay?
Yes, it is.
So the projects here, we have L, M, N, O, and P. So we have these for the poor, we have here for poor, for good, and for what? Excellent, not so. So it was what? 500. The other one is 470. The other one is 550. Then 400, 550, and 570. Then the other one is what? 450, 400, 475. The other one is 360, 400, and 420. The other one is 600, 500, 425. Are we together?
Yes.
So what are the probabilities? 0 point what? 0 0.2 and the other one. 0 0.2,
0.5.
0.5 and the other one. Okay, so 0 0.2. So here is 0 0.2, 0 0.5, and 0 0.3. Let us find EMV for M. EMV for L. What is EMV for L? It will be what? 0 0.2 on 500, then plus the 0 0.5 on 470, then the other one will be plus 0 0.3. So calculate for me 0 0.3 on 550. What answer are we getting?
Just a minute.
So what you do the same workings for other projects. M, N, O, P. You can manage that, right?
Yes.
Okay, I've given you some minutes to do that one. All right, so take your time.
Okay.
Okay. So in each of these, take the highest value to find the space value of certainty by 0 0.2, even here by 0 0.5, here by 0 0.3. Is that okay?
Okay.
Oh, let's see me quickly. Let me quickly audit the answers. The first one is what? 0 0.2 by 500 plus 0 0.5. You're able to see my whiteboard down by 470.
Yes,
Then the other one is plus 0 0.3 by 515. Is the one giving us 500, right?
500, yes.
That's for project. Now for project M, let's go for M. EMV for M will be what? Let's go for M. 400 by what? By 0 0.2 plus
0.2
plus 550
by 0.5.
0.5. Then plus what? Another one is 570
570
by
0.3.
0.3 equals 400 by 0.2 plus 550 by 0.5 plus 570 by 0.3. 526.
526.
Okay, so let's move on quickly. N, project N, EMV for N, we'll be wrapping up. So N is 450 by 0.2. Then the other one is 400, 0.5. So plus 400 on 0.5. Then plus what? The other one is 475 by what?
475 by 0.3.
By 0.3. 450 by 0.2 plus 400 by 0.5 plus 475 by 0.3. The answer is what? What did you find?
432.5.
Okay. Then EMV for O. Okay, so O is what? 0.2 by 360. Then plus 0.5 by what? 400.
100.
Then plus the other one is what? 0.3 by 420. So this one is giving us 0.2 by 360 plus 0.5 by 400 and plus 0.3 by 420. 398.
98.
Then the EMV for P is what? 0.2 on 600 then plus okay, so plus what? 0.5 by what?
0.5.
By what? 500, eh?
500.
Then plus 0.3 by what?
0.3. 425.
425. Okay. So this is the last one. It was giving us what answer? 0.2 by 600 plus C 0.5 by 500 plus 0.3 by 425. You found what? 497.1?
7.5.
Okay. So which one is the highest possible figure here? Okay. The highest possible figure is what?
526.
There is this one, 526. There is this one here, 398. So therefore, invest in which project? Invest in project what? Invest in project
M.
M with highest EM behind. Project M with the highest EMV of what?
526.
526. Okay, so let's wrap up. The other question says what? Check the question here. The other question says, so we have not done our 10 marks there. Calculate the value of the value with what? Perfect information, right? You're able to see this
Yes.
one. Value with highest perfect one. Okay, so we will come here. Let's find the other one I gave you. First, find is EVC. What is EVC? The expected value with certainty. Expected value with what? Certainty. So meaning EVC is equal to, you come here. What's the highest value here? 600, right?
600.
So 600 you multiply by 0.2, then plus the other one is 550, right? And the other one by 0.5. Then the other one is what? 570. Is that okay?
570.
By what?
By 0.3. 0.3 by 570.
By 0.3. Okay. So we can start the part by here. So this is 600 on 0.2 plus the other one is 550 on what? 0.5. Then plus the other one is 570 on 0.3. So expected value with certainty will be, so 600 by 0.2 plus the other one is 550 by 0.5 plus 570 by 0.3. So it's 566, right? So expected value with perfect information is equal to expected value with certainty minus expected monetary value. You remember this one, right?
Yes.
So it's a 566 minus monetary value, we found what? 526.
526.
So the answer we are going to is 5 minus 526. So the answer is 40. Is that okay? Is that what you found?
Yes, 40 years.
Okay, so thank you very much for understanding. So we can end here for now, but believe me, you need to send to your colleagues as many question papers as possible besides what we have, so that we can have more sessions before your exam, that you can prepare yourself for the exam. Is that okay?
Okay, sure.
Yeah, so we have just done 2 questions from here, but of course we need to exhaust all the questions from this assignment paper, then we can go to other question papers. So we can end here for now.
Okay.
All right then.
Thank you very much. At least I've understood.
Okay, no, that's good. All right. See you.
All right. Thank you.
Okay.